Hello and welcome to Apache TinkerPop's home here on Twitch. Today we have another TinkerPop Wide stream where we explore the wider TinkerPop community, looking at tools, libraries, or graph systems built on the TinkerPop framework, or even applications built on those foundations. Today we get to learn about Graph Explorer, an open source low code visualization tool for graph data. And we have its key developer here, Chris, who has been on this stream before in our graph visualization panel discussion a few minutes back to lead us through what Graph Explorer is about. We also have G.V luminary Arthur dropping in for some color commentary and other fun stuff. So awesome to have you both here. Thanks for joining.
Thanks for having me back.
Thanks for having me, mate. I just want to say I've been invited. I'm not just bombarding in.
We're happy to have you here, Arthur.
Yeah, fair enough. Cool. Well, with that, I don't have too much more introduction. Chris, I'll just turn it over to you. I'll get your screen up.
Sounds good. Yeah, I'm just going to run through a few quick slides just to kind of get this introduction out of the way, and then we're going to dive into some demos. So what I wanted to cover here today was two things. One, I wanted to introduce the brand new feature we've got in Graph Explorer, and also talk with Arthur about how these kind of complex UIs can be approached in different direction or different ways when we're coming from different perspectives. So we'll save that for the end. At the beginning here, I'll just kind of introduce the new feature in Graph Explorer. So with that, Graph Explorer, if you're not familiar, is an open source React tool that helps visualize graph data, but without needing an understanding of the query language or how the data is stored necessarily. The goal is to get you into exploring your data as quickly as possible. So this is very friendly for business users and anyone who's just looking to explore their data, maybe not dive in super deep with the technicalities. And it supports a wide range of query languages, including Gremlin, obviously, that's why we're here, and OpenCipher and Sparkle. And you can deploy it in many ways. You can deploy it using Docker in anything that runs Docker, or you can deploy it just straight Node and run it on your local machine. So it's super easy to deploy. We're looking to improve that later, but for now, those are our options. Arthur, do you want to jump in here, or do you want me to take this one?
Sure, I'll jump in. I'll be very brief. So, I mean, I guess the interesting part is you mentioned we've got divergent approach to an extent. I think we're coming for two very different angles. So I guess Graph Explorer, as we've kind of stated, is for business users primarily, ones that may not necessarily want to interact with the querying language or just simply don't have the skills to. GWT is the polar opposite. It's very much for the developers. In fact, we're calling it an integrated development environment for graph databases, despite the title on the website not saying that. And our approach is very much on the opposite end, but with the same goal to meet in the middle, meeting in the middle being access to graph visualization. So for us, it's about allowing users to write and run their queries and visualize the results in a number of ways, Graph, of course, being one of them, with the intent to help typically technical users, developers, refine and test their queries. And then also, we are aware, of course, that no-code exploration is quite an important feature for users. And so we're trying to diversify much in the same way that Graph Explorer is now diversifying, just meeting each other on each other's turf effectively. And we're also a desktop client, though we do have a web version on AWS Marketplace as well. And similar to Graph Explorer, we support multiple languages. Right now, we're still very much in the labeled property graph space. So Gremlin, Cypher, we're just about to release SQL 2023. We've got some other ones as well, such as Spanograph. But we will actually eventually have Sparkle support as well. A little bit of work to do on that. But yeah, that's GLB in a nutshell.
Ambitious. We're looking at Sparkle support as well. It is quite complex, but hopefully we can get there. Yeah, I'm sure you will beat us to it. You're so much faster at this. All right, let's jump back to Graph Explorer. So a few weeks ago, we released Graph Explorer version 2.0. This introduced the ability to execute manual queries within the UI and then continue exploring from there. Since then, we've released 2.1, which introduces OpenCipher support. And I'll run through all the little demos for the rest of this here. But that's the big takeaway here is now Graph Explorer, which was focused on a no-code solution, mostly UI-focused navigation, you now have the ability, not the requirement, but the ability to execute any query. So with that said, let's dive in, see what it looks like. Share the right screen here. All right. I have Graph Explorer running here. I'm doing this locally using our air route sample setup. You can find that in the GitHub repo. It essentially uses Docker Compose to launch Graph Explorer, the latest image, and a Gremlin server loaded up with the air routes data. And those are automatically connected for you, so you don't have to deal with any kind of connection setup. So that's all I'm using here. All I've done so far is I've customized the node colors and icons, just so we could at least tell what's an airport versus what's a country and continent, all that. And what users have had to do in the past to find their way around is either, hopefully, these initial results has what they're looking for. Like, say I'm looking for Atlanta Airport. I can start here. I could double click and I can start expanding from there. Look, DFW, my favorite airport because it is right next door. Where can we go from there? We can go to Anchorage, and I'm sure there's a lot more, 212 more. So you can kind of find your way through here, but it can be, it may not have all the options you're looking for, right? You may know you need to find an airport, and you may know maybe a city name, like let's say Los Angeles. So you can kind of find your way around. It looks like LAX is already in there. Let's clear that. So there's LAX. But if I wanted to find something more complex, like let's say I wanted to find all the airports that stop in LAX as a middle route, that's very difficult to do here. You could do it manually through expanding and kind of figure it out, but it's very difficult to know that that's what you're looking at. So we've added the ability to run any query here and visualize those results in the canvas. And I'll just kind of show just the most standard query you can imagine, which is exactly what the search is running initially, which is just give me the top 10 results from the database. No ordering, no filtering, no whatever. And of course, this can go up. You can do 100, you could do any amount you want. Once you go over 100, we start doing a little bit of paging down here. But completely unbounded. And we can add all these to the graph if we want. Not super useful, just a bunch of nodes presented in a square, right? So I'm going to clear that real quick. But all those capabilities are there. But we can start diving in a little bit deeper here. We can do the same kind of filters the other tab was doing, the filter. So we could filter down to just airports, get rid of that version entry. We can look specifically for DFW. And I'm going to start a new line here. Typing is so much harder when people are watching. boom, there we got DFW. You can expand from there. All this is pretty basic. Let's try something you can't really do in the search. Let me clear that. So if I just do a .out, I'm now starting at DFW, and I'm finding all of the neighbors for DFW. You could do that through expansion, but you would have to add DFW first. Now we don't have to. So I can add all those. We've already seen this. Not super impressive. Let's go a little bit further here. Let's do this. Let's say we're going to not search for DFW. I want to find all the airports, sort them by the number of routes, and just take the top 10. Super easy to do in Gremlin. You just need to order it by, and Steven, jump in if I'm doing any of the syntax wrong. This is me, not as a Gremlin expert, just kind of coming in here and saying, what can I do? All right, so we've got order by the route edge and the count of those edges. And we're going to do that in a descending order. And we want the top 10. Does that look right, Stephen?
Yes.
All right, cool.
I would have done out E, but because you're just counting
Let's try
edges,
that.
you don't need to go to the other side of the thing. That should optimize out though, but I always
There you
just
go.
type edges when I need just edges.
That makes total sense. But here you go. We've got our top airports. We can throw those in the graph if we want, and I'm going to get rid of the old table down at the bottom. So that's cool. That's something we can't really do in the filter. Let's try something else. Let's find all the airports that are in the California region. So if I do has region USCA, and we don't need the limit here anymore. Oh, I didn't do something right. I think I'm missing a parentheses, or I have an extra.
I think you've just
somewhere.
got an extra one. Yeah.
Yeah, there we go. All right, LAX, SFO, San Diego, yeah. All the ones you would expect. But what if I just wanted to see a count? So far we've seen a lot of vertices. What if I just want to see how many are there? We can do that. We could just see a straight up scalar if we need to. And from here, of course, things can get crazy. You could start saying, give me all the neighbors for all of those. Now we're at 222 nodes. So that's it's getting a little crazy. I'm sure you would want to filter that down a little bit more. But sometimes you don't want to just see vertices or scalars. You want to see like a fully materialized graph. So what can we do there? So let's change this up a little bit. Let's say I want to start at DFW. And I want to find if there are any routes that go through California. You can already see that my query box isn't quite big enough, so I'm going to expand it out. You can expand it that way. You could also expand it horizontally, but so far horizontal is looking pretty good, so I'm going to leave it like that. Let's see, am I missing anything? So we've got our neighbors, we've got our California, and last but not least is the dot path. This will make sure that we include the edges in the result set. And so you can see down here, I've got 12 nodes and 11 edges as the result. And if I scroll through, I can see my routes down here. So what I'm going to do is I'm going to add all. And boom, we've got a fully materialized graph. If you've used G.B before, you've seen this. This is not new material, but it's new for Graph Explorer. Before this, you had to start at a node and expand beyond that. So now you can actually build out a query, get a full set of routes, a full set of relationships, and display them all at once. Now, this is all great. You can explore further through this. There are a few things that we're looking to improve soon. And I'm going to show one of them now, which is, let's say you are looking at airports, and we're going to just pick DFW, just because why not? I guess I could have kept some of that around so I'd have less typing, but what we're going to do now is just give me the property values from that. So values, of course, is a value. Here's my Gremlin.
Well, it's values. I mean, you have to give it a
you have to actually give it one. Okay.
property name.
We'll skip that right now, but you could totally do that. So if I gave it code, which doesn't make a ton of sense because
no, you might have something
I got something else wrong. Has label airport.
Oh,
you're missing the V
at the beginning.
You're
missing the critical parts of the whole thing.
G.V, man. G.V.
Yep.
I don't think anyone's ever not typed the V. Like I've seen a lot of mistakes. I don't think anyone's ever skipped the V.
I bring a lot of special skills to this team. So. But there you go. So we're getting that code back. But let's say you want the lat. There you go. But the limitation isn't that. That works perfectly fine. Where we so far aren't doing what we want is if we're getting back a map. So you can see here, we're actually displaying results just fine, but we're not displaying it in the most optimum format. Because really what you have here is a key value pair. So we've got a country is US, code is DFW, longest. Anyways, we could format this way better, and we're looking into that. And, same type of deal in this other example I've got here. So like if you wanted to do like a group count, which is not something that I knew Gremlin could do until yesterday, so that is awesome. But I want to find the number of airports in each country, but that's a pretty long list. So I was going to just select a few just to make the list a little shorter. And I was going to do all of the countries we're kind of working out of. So I'm in the US. I know Arthur's in the UK. And Stephen, are you in Seattle? Is that right?
No, DC area.
You're in DC area. Okay. Well, I'm working with some Canadian folks, so I include that for them. So we could definitely do better here. We're working on it. This is not the end of the query editor. This is just the beginning. But as far as examples go, that's what I had. I think this is a super exciting new capability in Graph Explorer. It's not required by any means. Stephen, I'm glad you used the word low code and not no code, since we have now introduced
code.
Yeah. So it makes Graph Explorer way more powerful than it was. And gives you the ability to do the kind of filtering that maybe you wish Graph Explorer could do, but doesn't quite do currently. So, as Apple likes to say, we were excited to see what you do with it.
Yeah, it's really cool to see this finally in Graph Explorer. Just having just even a little bit of an ability to, execute some Gremlin inside of the tool. I mean, that's like. Just even some basic results and things. I think that's incredibly valuable. In addition to just your exploring, I feel like you need one kind of with the other in some sense. So yeah, very good.
For sure.
Yeah, I think it's really good that you also came out immediately with support for path queries, for instance, because they're ultimately the ones that are going to result potentially in the most useful visualizations. They obviously require a little bit more effort in terms of writing the query, but they're also kind of the highest rewards query structure, I think, when it comes to graph visualization, because typically when you're looking to explore your data visually, you're inevitably going to traverse your data and you're going to try and figure out paths within that data. So you're basically providing a way to, rather than expanding your data incrementally until you get to the point you want to, you're giving the option for users to write the path query, which can take some time to figure out. But if you think about Cypher, for instance, Cypher does make those path patterns very easy to express. So that I would argue it's actually fairly accessible to someone who has a basic grasp of not necessarily graph databases, but just a little bit like we've seen in a couple example queries. So I think that could allow for some really interesting thing for users to just get a path, because ultimately that's what we tend to want to see when we use these visualization solutions. And I think coming out with that means you're providing it from day one as a capability.
Yeah, I can definitely agree with you that it was not simple to do.
Yeah,
there was a lot.
I can also sympathize with the handling of scalar values. I've been there to some extent myself. I believe where it gets a bit challenging when you want to allow users to write any queries and to provide them a useful display of the results is you inevitably have to look at the results and understand the structure, so you can then decide how you're going to display them. And especially when you're doing more than one language, because each Gremlin has some of its own structures, nodes, and vertices and edges rather. Cypher has and paths as well, mind you, and trees and graphs. Cypher doesn't have as many actually, which is nice.
It is much
makes
nicer,
it all easier.
yeah.
But you do have to contend with like several different data structures through multiple languages, and that can become a bit more challenging to not miss one as you go, and to also find the appropriate visualizations. I find personally that maps and lists in particular can be a bit more challenging to display because you can't concisely. And I actually do find it quite interesting what you've got display there, because you're saying it could be displayed better, but at the same time, it's actually displayed in a really holistic way. You can actually see the entire map there. It's maybe not necessarily clear that it's a map, but you can actually see all the values directly. Whereas typically, for instance, on G.V, if you had a map value, you'd see a sort of summarized version of it, but if it's too big a map, you'd end up missing quite a lot, and you'd have to expand it to see it. So I do think there's actually some benefits to the approach you're taking here. I wonder if it's maybe a case, for instance, of using indentation a little bit in the UI to signify the structure that you're working with.
Yeah, we haven't settled on a UX for it yet, but at least for this, I'm pretty sure we could do a single row that is like a key value pair. So similar to what we would get. Oh, I guess I grabbed everything, but similar to what we do here.
Yeah, I think that makes sense.
Yeah, I was kind of curious what you would do with like a more complex object if you had a list with an embedded map and something else inside that, how that ends up being displayed.
It'll likely take a form similar to this. The question is always like, what is this root node? Like, is it just like a count of attributes or values inside of it? Does it just have the title list? That root node just becomes a little tricky.
I would say actually on that, I had a similar challenge in G.V. So there's the graph visualization. You can see stuff as tables, and then we also got this results display, which is essentially an object browser. And one implementation that I really liked is what memgraph lab does with this. And we've kind of replicated the structure UI-wise of what they've done. They essentially display the types of elements that are being returned, but with a little bit of color coding and a little bit of clever, indentation and sizing of text to very clearly signify the containment of the various objects. To give you an example, if you had a list of maps, the way that ends up displaying is as list, open curly brackets, map, open square brackets, apologies, is a list. And then map, open square brackets, show a little bit of the content of that map, close that, comma, etc., etc. And that actually ends up looking quite elegant with a dot, show 10 more, which is what we ended up doing as well. And it actually works really well to summarize complex structures without losing the entire value of displaying its values. Because like you're not seeing all of it, but you are getting to see some of it, and you're being strongly indicated that there's a little bit more. And so if you want to find that little bit more, click and you'll see that.
Expand, yeah. I like
So
that idea.
I would highly recommend looking at that, and I guess look at the one that we've got, because we've done something very similar as well. And where it gets interesting as well is you can detect types of elements. Right? You can detect something as a node, you can detect something as an edge.
Oh yeah.
And you already have styling in place in your user interface that governs how you're displaying these elements in your graph visualization and your results view. You can actually leverage those in those summary views as well, and it actually starts looking quite interesting.
Nice.
Because suddenly everything is color coded according to the scheme that the user knows and has ownership of, and that means it's very instantly recognizable.
That's great. But you brought up what you've been doing. Is there anything you wanted to share? I'm going to kind of put you on the spot here because I invited you on to kind of chat back and forth about, just queries in general. But I've got you here. You've got your own product. What you got cooking?
So I think this was interesting because we did talk about it the other day, and Graph Explorer is sort of venturing into an area that I've kind of started with. And I'm kind of taking a reverse journey here where I'm sort of venturing into some of Graph Explorer has been doing. We've had historically some no-code exploration features in G.V, but they weren't necessarily very well designed in the sense that they did not allow to fully exploit the value of, half traversal and just general capabilities of graph databases. And so in our latest release, we've kind of reworked our Graph Data Explorer to offer a query building UI that's much more aligned to what the general goals of no-code query building are. So what I mean by that, and I'll maybe show it in a minute, is typically we're kind of briefly mentioned, but we're looking for pathways from one place to the next with perhaps some filters. And we've taken some inspiration to an extent from what Neo4j Bloom offers in that space, and delivered a new user interface that's set to release next week, actually, that allows you to build those paths in a no-code fashion with filters, et cetera, and then get to graph visualization. So I guess I can probably contextualize that a little bit and give a little demo if I can share my screen. Let's see.
Sure. Let me stop mine.
I'm going to go with stream number
Sounds
one. I'm just going to share the
exciting,
entire
by the way.
screen. It took a lot of work. One of our challenges, and I think you have the exact same challenges we do, is that we're compatible with a lot of different databases and languages. And as soon as we're talking about generating queries, one language, that's going to be once the work, two languages, it's going to be twice, thrice. I think we're about 5 times the work right now. So that's keeping us very busy. But I've got a little Janus. So this is G.V right here. Conveniently, I've also loaded their routes, which is kind of my go-to. I've loaded mine in Janus Graph. And we have this Graph Data Explorer right here, and this is basically our new query building guy. So for those that have maybe used G.V, you'll remember the sort of filtering panel on the right-hand side, which used to allow you to select a vertex and filter it, and then just go and fetch the relationships from that. And so what you'd end up with is a very one-dimensional traversal where you're just grabbing a bunch of vertices and then fetching their neighbors. And that's as far as you can get, which really does not allow leveraging the actual capabilities of the graph database, which tend to perform better, or best rather, at traversals, complex traversals. So we've taken that and we said, cool, let's try and fix that. So for instance, I can start expressing a path here. So I'm going to filter my country a little bit. I'm going to take the United Kingdom because why not? There we go. And then I'm going to select my airport. And we're going to take all the routes from the UK to, let's say, France. So if I've expressed this correctly, what we should have is, let's find all the airports in the UK. from the airports in the UK, let's find all the routes to the airports that are contained in France. I'm going to limit the results just a tiny little bit because that could get a little bit busy, although I suppose there's not that many airports. And we're going to run that. Cross our fingers very hard that I've not made a mistake and that it's going to work as expected. And there we go. Right.
Wow.
So what we have now is our graph, which I'm maybe going to lay out slightly differently to allow for, there we go, a better display. And
that's nice.
I am noticing some duplicates here, which is something that I should probably address. But it allows us to express our path query in a sort of no-code fashion and then just see the results. And we've kind of taken that approach as well, just one tiny little step further, which is sometimes you may be a starting point in your graph where you can view stuff, but you want to pick a specific node and you're going to load more stuff from that. And up until now, we'd allow loading immediate neighbors according to specific labels as we understand them from the structure of the data. So we've kind of taken this and we said, okay, well, that's not doing what it's supposed to do, unfortunately, but we're allowing to filter specifically by ID. So it's not doing it here, unfortunately. So that's a little issue, but it would allow you to essentially search a path from a specific node. There you go. And then go and find the path from there. So that just allows you to express a path from a starting point that is well defined without necessarily having to go and put the filter in yourself. So that's
really
one of the
nice.
things we've been working on, and I think that's the main one that's of interest to this conversation. And for us, the path query building is probably it's actually the easiest to do, first of all, worth pointing out, compared to other query building exercises. Because when you start talking about query building, say you want to give the users an interface to build aggregation queries, for instance, it's going to be very difficult to figure out the user experience. That's not going to feel very intuitive because ultimately the problem you're trying to solve as far as the no-code query builder goes is complex. And so the UI is kind of inevitably going to end up complex as well. But with Path, the kind of cool thing is that is super easy to understand. Like if you're looking at it, you can very quickly understand what we're doing. Airport is contained by, you can see our little arrow is pointing to the left. Country, if I do it the other way around, contains, that's going to be like this, etc., etc. And so that just makes it a little bit easier to read what you're actually filtering here. And so when we put our filters as well, this one's not actually going to be interesting because there's no property on contains, but if I want to select a specific country, can do this, and then we'll see, cool, country contains airport that happens to be in country equals US. This data set is a little bit counterintuitive with the properties here because that actually states the same information, but everything is kind of very human readable, and that therefore makes it a lot easier to interact with. So yeah, that's the main thing that we've been building recently that is going to be relevant to the TinkerPop community. Besides that, I guess we're still very much in our journey to support all of the graph databases, which is in itself kind of an impossible journey, but we're making strides. We're actually adding support for Oracle Graph, which is the first implementation I'm aware of that leverages the SQL 2023 standard, which introduces path pattern matching on top of relational databases. So it's one of those examples of graph on relational, I guess, that we're quite interested in because, when we think about relational data, that's what most people have come into, typically, through their education and then their jobs. That's been my journey personally. And so to see the relational database industry invest the graph space to an extent with these new standards and these new capabilities kind of signals a potential shift, and entry of a lot more users that are not going to be familiar initially with these concepts, but are going to have access to them pretty easily from their existing relational structures. And then, they might choose thereafter to specialize their data to a graph database. They might choose to stay on graph and relational, but either way, they're getting introduced to these concepts, and the idea of, the benefits of graph become a lot more ubiquitous in the sort of general database community, because I guess it's kind of worth remembering that relational still very much dominates the database market. So I think that's a really interesting move. And that's most of what we've been up to. We actually did some really significant improvements to the Gremlin also complete. This is an issue I've been struggling with for years around making quality suggestions for nested traversals. Super annoying. I finally cracked it a few weeks ago, and I've got it working a lot better. So I thought I'd mention that. There's a type of stuff you're probably not going to notice, but I know it's there. It took me quite a while to do it, and I'm very happy to finally figure this one out because it's been a while. And then for us next is really just moving to RDF support and Sparkle, which is interesting and certainly requiring a little bit more expertise, sometimes external and sometimes us just trying to learn. But we're hoping to have something in August, hopefully. I'll leave it at that. That's kind of all I got going on at the moment. But I think it's quite good that we're essentially exploring each other's sides in our respective solutions. And I think the really good thing is, and I make no secret of it, even in this call, I take inspiration from other solutions that are available out there. I like to see what works. I like to see what doesn't work, and I like to see what could work better. And I try to take all these things and say, okay, this is a good idea. How do I apply it? I see the benefits as a user, and therefore I want to deliver that same benefits to my users. And on that note, let me just show you that one thing actually that I mentioned about our data structure, because I think you'll really appreciate that. So this is our results view, and there you have it. There's a list of paths. We can see the first path, we see there's 98 more, etc., etc. And so if I make it a little bit more complicated, .env dot out hopefully that won't be a tricky query, but you can see the structure evolves as we're complexifying the query and we're retaining the color coding of elements. And that means
nice.
It's very easily readable. And I'd recommend taking that approach on Graph Explorer. Now, that is not something I've come up with, to be perfectly clear. That is very much a memgraph lab invention, as far as I know.
Interesting.
But you can also see I'm using the way we're labeling elements on the graph to label these. So you'll see, for instance, the airport is going to show its description because that's what I've picked in the graph.
It's so funny that you also picked purple for airport. I guess airport
default color scheme, but yeah. Let's see, if I change that to ICA, which I have no idea what that stands for, you'll see that changes it here as well. So I wanted to show you this because I'm actually super happy.
Really cool.
I put this in place a few months ago, and frankly, when I saw this on memgraph lab, I was like, wow, this is really, really good. I need to have that as well.
Yeah. As far as the sub panel of that goes, that's kind of similar to what I've been considering, but I love the way that lays out on that root node. That looks really, really nice.
So the only challenge I think is horizontal space with this type of display. Because you can see it very well. I've not got it on screen anymore, but it gets very busy very quickly. And so if you're horizontally challenged in your user interface, then that can be a challenge. But I think the interesting part is, like, vertically, you've got a lot of space. So you could take a slightly different approach where instead of laying things out horizontally, you can actually lay them out vertically instead and allow some items to span multiple lines in your UIs to signify that complex structure. And that means, the taller the item is, the more complex the structure, and you're making, the most efficient use of the space that you have, which is a problem that I very frequently run into, especially now that I'm working on RDF support with our RIs that are absolutely massive.
Prefixes are your friend.
Figured out yet, but yeah.
Definitely get it in with prefixes.
Yeah, I think that's gonna have to be something along these lines. I'll figure it out at some point, hopefully. Or I'll just let it be IRIs everywhere. Maybe people are just used to them. Who knows?
Maybe. But yeah, no, thank you for showing me that, because that is really cool. And I'm going to check out I've seen memgraph before, but I haven't done a deep dive on it. So I'm sure there's stuff we can glean, like take inspiration from. But on that topic, I mean, I think all of us are taking inspiration from each other because the field is so small right now.
Yeah.
There's no clear leader of the pack, right? Maybe Neo4j Bloom excluded because they do have a large team there. Um, but if you exclude them, there's no clear, this is the de facto way to do it.
Yeah, yeah, I agree, and I think there's been lots of very different approaches being taken over the years. I have seen a propensity for databases implementing those tools to adopt the Neo4j browser user experience,
Mm-hmm.
which is the single line query graph visualization panel underneath that can be stacked vertically on top of each other. Um, Personally, not a big fan. I'm very much a fan of the tabs that I've been used to for many
Yeah.
years as a relational database user. But I think that has been clearly a big inspiration in a lot of implementations. I don't know whether it's actually attributed to Neo4j or perhaps to OrientDB. That could be another one. I'm not sure which of the two actually came up with it first. But I've definitely noticed if you look at specifically, I think particularly rather in the Cypher space, that is the predominant user experience format. Whether you're looking at memgraph lab actually, or Kuzu Explorer, or Falcor DB Explorer, etc., they all have taken the same approach of single line query visualization underneath. And that's just, it's about priorities in terms of the user experience. They're prioritizing the visualization of the results against the query editing experience effectively, which to some degree makes sense for Cypher because Cypher can be quite concise in terms of
Mm-hmm.
actual query length. The downside of that being, well, if your query gets complex, then you're going to be vying for space, but typically they'll allow the editor to get a little bit taller to account for that. So there's not a definitive answer. My personal take is the definitive answer is do what the relational databases have done, because they've been
Mm-hmm.
around with these user interfaces that are used by millions of people for decades now. And that must therefore mean they've figured it out quite well. But
Mm-hmm.
that's just me.
Yeah. No, I think that's a good approach because, like you said, everyone's familiar with relational databases. Um, let's see. How G.V does some really amazing things in a very quick way. I will say that Graph Explorer has struggled with this a bit, and we are working on making it faster. But with manual queries specifically, I found that I need to perform additional queries after the initial query. Do you find you need to do that as well?
Absolutely. Yeah,
Yeah.
absolutely mandatory. And that is true of Gremlin, that is true of Cypher, and that is true of practically, not always, but most other languages as well. Gremlin, I think, is probably the best example, although nowadays it's not as much the case. For those who have been using TinkerPop prior to version 3.7.0, you'll maybe remember, though it wasn't that long ago, that when you returned a vertex or an edge, that did not include its properties. You had to either get those with property map or values, value map, element map, you name it. And so in the context of Graph Explorer, for instance, I guess this is probably what you've had to do is when you're receiving vertices or edges in your queries, they're not going to be very useful without their properties because they're just going to be a label and an ID that's not going to allow the user to, disseminate them because
Mm-hmm.
unless they happen to know the mapping of every single vertex ID to what they actually contain, which is fairly unlikely.
Yeah.
And so what you typically end up having to do is fetch the properties. And so that tends to be your follow-on query. I've got a
Mm-hmm.
list of vertex IDs or edge IDs. Go and get me the properties for those. And this is where you're going to then leverage element map, maybe your property map, to get those. And it's relevant. It's very efficient, right? I mean, we're really just talking
Fairly.
about querying things by ID, so it's not going to be expensive on the database. Volume might be a factor, but it's only going to be a factor in the sense that there's going to be a higher data transfer volume, not so
Mm.
much a really complex query. I mean, you could say G.V
No.
pop an array of 1,000 IDs, that's not going to cause any issues, right?
Unless we are working on that now, but I think I limited it to 100, not quite 1,000.
You
so I'm
could,
gonna do batches of 100.
Yeah, so I suppose in your case, and that's really interesting. I think in your case, you've got an opportunity to have higher performance because, unlike GLV, for instance, where like, we'll just throw everything in, let's go. You have the ability to page. Well, we do page things. We page things after we fetch everything.
That's exactly what I'm doing. Just to be clear.
Yeah. And in your case, you're able to say, well, when we next fetch another page, we can go and fetch the properties for those elements. That means everything is nicely chunked, and you're kind of avoiding retrieving more data as needed. And I think it's because Graph Explorer takes the approach of giving users a choice of what they actually want to include in the graph visualization as well, which I think is really interesting. That's something I kind of wish I could do.
Still not 100% convinced it's the right approach, but I prefer to go that direction because we're talking about a bunch of users who are used to search, seeing that search result and then choosing which result they're interested in. So I didn't want to go from that to run a query and immediately plop it in your canvas, which may have other nodes or edges in there.
Yeah.
Right. And
so
I wanted
think
to take kind of a
better
preview
approach. I think it's a better approach. The way you've described it of users are searching for something, I think is really important in this case. They want a starting point. And so you're essentially giving them the opportunity to pick that starting point before we start flooding the screen with information. It's kind of worth remembering with graph visualization that you can only have so many data points on screen before people are like, too much. I'm not ingesting the information anymore. So I think that's a really smart approach.
How much is properties on elements that came, I guess, in 3.7 help change anything that you're doing?
Is that a question for me or for
either of you? But I don't think Chris probably hasn't made use of it yet.
I can't rely on it.
You can't rely on it because it's
not. I have to support older versions of Gremlin, so I have to assume the properties aren't there. Unless they're included in the result. If they're in the result, I'll say, cool, I got properties, don't go fetch them. But if they're not there, I don't know if they were supposed to be 0 properties or there are additional properties to go get. So I have to assume and go get it.
Yeah, the way I've done it is I wanted to do it that way first. That's the way I thought would be best to do. I'm not saying you don't have the best way to do it. Sorry, that's coming out wrong. But the way I ended up doing it is by looking at the Gremlin version instead and using that to determine if it may include those properties. But there's some additional complexity with that because depending on who the provider is, they may or may not allow these by default. So, for instance, maybe Janus Graph on 1.0 and above will be leveraging TinkerPop 3.7 and above, and they'll have materialized properties, I believe is the name, enabled by default. But then maybe, and I actually don't know the answer to that, I can't remember, maybe Amazon Neptune doesn't have it on by default on engine version X, Y, or Z, but then they have it on in engine version A or B. So there's some additional challenge. I actually would need to double check the code on how I've cracked this, because that is a very, and that's where the complexity really starts rising, is trying to consolidate the different tunings of versions of TinkerPop and deployments of TinkerPop to provide a consistent user experience. And I think it's not necessarily a TinkerPop problem. I think it's rather just there are many vendors, there are many implementations. They're not going to all agree on the best way to do things. Some people might say, well, we don't want to materialize properties because we want to keep the data stream as low as possible when people are running queries. Others might be, well, this is coming at a cost of user experience failures or developer experience failures. Therefore, we do want to include them, accepting that the higher transfer costs in terms of data are acceptable. So there's very much different ways to approach it. And I think ultimately each vendor has it to their own, unless if you're deploying it yourself, in which case you can just decide. But again, those users might not all decide they want to materialize properties. So you're always left to kind of decide between the two.
And I
think
would
that's
say,
really interesting.
I'd say in addition to what you just brought up, when you were saying that all query languages kind of have this issue, it's I, I think I brought this up on the panel last time we were both on the stream. The languages are generally defined and focused on making an application that knows the data source really well and
Yeah,
making those queries optimized, where you and I are building a generalized tool knowing nothing about the data source and its shape and trying to make it work. Um, so we're in some ways forcing a square peg through a round hole, but um, honestly, I think both of us have done a decent job at that, right? Like it's
yeah,
totally possible. It's just not easy.
yeah, absolutely. And I actually did double check the answer to the question, how do I know whether it supports those properties or not, is kind of interesting. Uh, it's a kind of two-pronged approach where I'll actually first look at the strategies that are enabled when I run a g.get strategies. If the reference element strategy is present in the list, then that means they're going to have the properties. If
Ah,
it's not there, then that means, it doesn't have the properties. If that fails because you can't always get the strategies, then I'll look at the version. I'll say if it's a 3.7.0 above, I'm assuming they are there. Otherwise, they're not. And so I think what that covers is for those that allow, like for those deployments where people have control over materialized properties, that reference element strategy will be there. And for deployments where you don't have that level of control, I'm relying on the decisions I've taken, which happen to be consistent around, well, we're just going to go and have them if we're 3.7.0 and above, which is part luck. It's actually technically impossible to assert every scenario, and there could be failings, but that seems to be covering most cases as far as I can tell. So I think if you want to have a way to determine these things, yeah, I'd say check the strategies and check the version number.
Kelvin actually posted something in Discord, a little more technical thing here. Graph Explorer using HTTP plus GraphSon. Does GraphSon already have the properties anyway in that case?
for most situations, yes. So if you're getting a vertex or an edge directly, absolutely, they'll always have the properties. Um, where I found they don't always include the properties is when dealing with a path. So if you've got a path that includes vertices and edges, sometimes the properties are included. I think maybe in the vertex case, but not in the edge case. Relation case, not edge case.
Yeah, I believe
Yeah.
that's the edges where the properties get excluded. I actually remember we've had that conversation a very long time ago.
I
So
honestly don't know why that is.
yeah, uh, I could
Yeah, I
I
don't.
could dig that out, but I think there's definitely, and I think you did come up with a good reason for it as well at the time, which was, I can't remember what it is now,
I
but
can't remember
I believe
either,
there
but it
was
may be
something
a
around it. Yeah.
Neptune specific
No, that's a
thing.
consistent behavior. I've
Okay.
seen it
Okay.
on Airspy Graph as well, I believe, and probably Gremlin server. I need to double check,
Okay.
but yeah, there's some constraints there. And I think sometimes the approach is just fetch the properties regardless. Sometimes the easiest
Like you
decision is to
said,
not
it's
have to decide.
inexpensive. Yeah, exactly. Yeah, my deciding point is, are there properties right now? And if so, don't fetch them. If not, yeah, I might need to fetch them, so go fetch them. So,
Okay, cool. Were there, I don't know, any other things? Maybe what's coming next with Graph Explorer?
so next we're working on the key value pairs and the groupings. So those results will look a little bit better. Beyond that, we also have some performance improvements coming. So those additional requests we were talking about executing, those are going to be batched up. Right now, they're all individual requests, which can have a tendency to overload the browser a bit when you flood it with 100 requests or more. So batching those up will help a lot, reduce the chance of getting any kind of throttling errors. So that should be released soon. And then after that, we're going to look into making the editor experience a little bit better. Right now, it's just a plain text box, so you don't get much of the editor experience. So we're going to look into improving that.
Okay, sounds good. All right. I don't see any other questions at the moment. I wasn't sure if anything else we wanted to go over.
Only to reach out to us with any feedback. Go on our GitHub, AWS, or it's github.com/AWS/graph-explorer.
Yep, I
I'm sure
shared
we'll put
those.
links everywhere. Yeah,
Yeah, the links are in the chats. So, yeah, people
perfect.
have it.
And Arthur, for you?
Nothing from me other than congratulations on the release. I think this is a really, I mean, you've gone for, from 1.0 to, well, 1.x rather to 2.x, and that's a big deal. So congratulations on making that leap. I think it's really exciting to see these new people, these new features and capabilities come from Graph Explorer, and I'll be sure to have a look regularly to see what you guys are up to and if there's any ideas I can steal.
Absolutely. Yeah.
Cool. Well, thank you both for joining here today. I appreciate the demo, and yeah, we'll see you all in the next one. And I'm going to try and exit with a different button on this thing and see if it actually works. So if this is like a disaster, weird things happen, it just happen that way. So thanks again, everybody. Thank you for joining the stream. Take care. Bye.
Take care, everyone.
Bye.
Yeah, see, that didn't do what I wanted it to do. Okay.
Well, Arthur rage quit. He's like, I'm out.
All right, here we go.